Hello everyone, today we're going to explore the mysteries of planetary and lunar motion together. Did you know that the orbits of planets are similar to the Earth-Moon orbit? And where is the center of mass between stars and planets? Let's begin with these questions. First, let's briefly learn about Kepler's laws. Kepler's laws are three rules that describe the motion of planets around the Sun. First, the orbit of a planet around the Sun is an ellipse, with the Sun at one focus, not at the center. Second, when a planet is closer to the Sun, it moves faster along its orbit. When it's farther away, it moves slower, but the area swept out in equal time intervals is the same. Third, the farther a planet is from the Sun, the longer it takes to complete one orbit. The cube of the distance is approximately equal to the square of the orbital period. Question 1. Although both planetary orbits and the Moon's orbit conform to Kepler's laws of planetary motion, they differ greatly in terms of structure, scale, shape, and other aspects. First, differences in scale. The radius of a planetary orbit is enormous. For example, the average distance between the Earth and the Sun is about 100 million kilometers. The radius of the Moon's orbit is much smaller. The average distance between the Earth and the Moon is about 380,000 kilometers. Second, although both are elliptical orbits, planetary orbits are usually closer to being circular, with very small eccentricities. The Moon's orbit is slightly more elliptical, and its shape undergoes periodic changes due to the influence of the Sun's gravity. Third, the reference centers are different. The focus of a planetary orbit is the center of mass of the star. The focus of the Moon's orbit is the Earth, but the common center of mass of the Earth and Moon is not at the center of the Earth. Rather, it is located within the Earth, slightly offset toward the Moon. In questions 1, 4, and 7, where is the center of mass? In question 1, the center of mass is inside the star. In the star-planet system of question 4, since the mass of the star is much greater than that of the planet, changes in the planet's mass do not significantly affect the planet's orbit. However, when the planet's mass increases, the center of mass shifts slightly outward from the center of the star. When the star's mass decreases, the center of mass moves closer to the center of the star. In question 7, an increase in the star's mass will bring the center of mass of the star-planet system closer to the star. When the star's mass decreases, the center of mass of the star-planet system will move away from the star, shifting toward the planet. How does the center of mass in a planet-moon system differ from that in a star-planet scenario? There is a significant difference between the centers of mass in a planet-moon system and a star-planet system, which stems from the large disparity in mass ratios between the two types of systems. This results in the center of mass being located differently relative to the primary body. In short, the fundamental difference between the two lies in the magnitude of their mass ratios. The mass difference between a planet and its moon is relatively small, causing the center of mass to be located farther from the planet's center. In contrast, the vast mass difference between the Sun and a planet means the center of mass is almost coincident with the center of the Sun. Question 2. When the grid lines are enabled, what is the distance between each marker point? According to experimental records, the distance between each marker point is approximately 0.4955 AU. Question 3. Record 4 sets of data. These results are consistent with Kepler's laws. Here are the 4 sets of data I recorded. Question 4. Which planet in the solar system do you think has the fastest and slowest orbital speed? According to Kepler's laws, the closer a planet is to the Sun, the faster its orbital speed. In the solar system, the planet closest to the Sun is Mercury, so Mercury has the fastest orbital speed. On the other hand, Neptune is the farthest from the Sun, so Neptune has the slowest orbital speed. In this experiment, we focused on planetary and lunar scenarios involving differences in orbits, including scale, shape, and reference center, the effect of mass changes on the position of the center of mass in star-planet systems, and the differences between the center of mass in planet-moon systems and that in the Sun-planet system. These topics have deepened my understanding of Kepler's third law